I am Ananya Ghosh, 20 MIC 0063, and I will be presenting a presentation on comparative analysis of consensus mechanisms and scalability, Hedera Hashgraph versus Ethereum. We come to the introduction. Hedera Hashgraph is a distributed ledger technology designed for high-speed, secure, and fair transactions. It employs a unique consensus algorithm known as Hashgraph, which offers a near-instant finality and high throughput, making it suitable for applications requiring real-time interactions and micropayments. Hedera's Council of Large Corporations governs the network, contributing to its large scalability and security. While it has growing ecosystem, it's often chosen for enterprise solutions and applications that demand quick, efficient transactions. Ethereum is one of the pioneering platforms in the blockchain space, operates as a decentralized global computer for executing smart contracts and decentralized applications dApps. Ethereum has been a significant driver of the DeFi or decentralized finance and NFT, non-fungible tokens trends, enabling a huge range of innovation in blockchain-based applications. It initially employs proof of work for consensus, but is transitioning to proof of stake in Ethereum 2.0 to address scalability and energy efficiency concerns. Ethereum's ecosystem is vast, fostering development across various industries and use cases. So in the further slides, we will compare these two. So comparison based on the consensus. So first I'll explain how the consensus works for both of them, and then we'll compare. Hedera Hashgraph consensus. So in this Hedera Hashgraph consensus, it uses something known as a gossip consensus. In gossip consensus, the nodes communicate with each other and they share the information about the transactions that are pushed into it. This information is then used to create a graph of transactions, which is called a directed acyclic graph, DAG. Then it is determined to the order of transactions and prevent the double spending. So gossip consensus works on like a node is created when a new transaction takes place and it sends it to the neighbors. The neighbors then forward the transactions to their neighbors and so on. Each node maintains a copy of the DAG and updates it with the new transaction as they arrive. Nodes then use the DAG to determine the order of the transactions and to prevent double spending. Gossip consensus is very efficient and scalable consensus mechanism. It can handle large number of transactions per second and has a very low latency. So in the diagram, we see how the consensus algorithm works. So these are the users: Alice, Bob, Carol, Dave, Ellen. So once the transaction is initiated, it is sent to all the neighbors, and then once it's approved, it is and everyone has a copy of the transactions. So these are the step, signature, timestamp, transaction hash. So we'll see this in next slide. So Hedera breaks down the core concept of consensus algorithm into transactions, fairness, gossip, hashgraph, gossip about the gossip, virtual voting, famous witnesses, strongly seen. And so we one by one we discuss each. Transactions, any member can create a signed transaction at any time, and all members receive a copy of it and reach consensus on the order of the transactions. Fairness, it should be difficult for a small group of attackers to influence the order of transactions. Gossip, each member node randomly selects another node and then tells them everything they know. Hashgraph, a unique data structure for taking into account who gossiped, with whom, and the records the order that it occurred in. Gossip about the gossip. One of the critical features of the mechanism, this is the hash graph spreading around throughout the gossip protocol. Since the hash graph contains the history of the gossip from each node and the order, this process is empirically just gossip about gossip that already happened. A significant result is that a very little bandwidth overhead is consumed in this process. Virtual voting, where every member node can reach agreement on any decision without any vote ever being sent, because every node has a copy of the hash graph. Therefore, each member knows exactly what another member would have voted without actually having to go through the voting process. Famous witnesses. This is where the community selects a few vertices in the hash graph known as the famous witnesses, where each is a witness of the transaction that is received by the majority of the nodes comparatively early in the gossip process. So by doing this, they can come to consensus much more efficiently on order of the event of the hash graph. Finally, strongly saying the proof of Byzantine agreement with probability 1. It is where two nodes can independently calculate the same virtual vote of a third node because they come to the same conclusion on the connection between two vertices within the hash graph. The architecture of the Hedera hashgraph platform consists of three structures. So the internet layer, the bottommost layer, computers on the internet communicating by TCP/IP connections with TLS encryptions. Then above that, in the middle is the hashgraph consensus layer, the nodes throughout the network that participate in the gossip protocol and the hashgraph consensus algorithm. All nodes maintain an identical consensus state. Service layer, the topmost. This layer consists of its own three subgroups: cryptocurrency, file storage, and smart contracts. Here we see a diagram of difference of how blockchain is and how hashgraph looks. Ethereum consensus. So Ethereum currently uses a consensus mechanism called proof of work. In proof of work, miners compete to solve a complex mathematical problem in order to earn the right to add a block of transaction to the blockchain. This process is very computationally extensive and consumes a lot of energy. Proof of work works as follows. The miner collects the pending transactions and creates a block. The miners then compete to solve a complex mathematical problem. The first miner to solve the problem broadcasts their block to the network. Other nodes verify the block and add it to their copy of the blockchain. Proof of work is very secure consensus mechanism, but is not very scalable or energy efficient because of its extensive requirement of computation. However, Ethereum is in process of transitioning to a new consensus algorithm known as the proof of stake. Proof of stake, where validators stake their Ethereum's ethers in order to secure the network. Validators are then randomly selected to verify transactions and add blocks to the blockchain. POS is much more energy efficient than proof of work. So here we differentiate between proof of work and proof of stake and show how the process is working. So in proof of work, to add each block to the chain or miner, the miners must solve that difficult puzzle. And whereas in proof of stake, there is no competition, but they need to have some Ethereums at stake. So next is, in order to add a malicious block, you have to have a computer with powerful more than 51% of the network, which is almost impossible. So it's very safe. In this case, you need to have 51% of all the cryptocurrency of the network, which is also extremely difficult for a hacker to have. The first miner to solve the puzzle is giving a reward, and here there is no reward for making a block, so the block creator takes the transaction fee. Next is, which consensus mechanism is better? The best consensus mechanism for a particular use case depends on the specific requirements of that use case. Now, if scalability and energy efficiency are important, then Hedera hashgraph is considered. But if security is more important, then Ethereum is considered. We'll see more about this in upcoming slides. Examples for Hedera. So in Hedera, it is well suited for high throughput and low latency, such as micropayments and supply chain management. So Hedera Hashgraph is being used in governing council to develop micropayment process platforms known as the Hedera Micropayment Network. In Ethereum, it is well suited for cases where decentralized and tamper-proof ledgers are needed, known as decentralized finance or non-fungible tokens. For example, it is used in development of DeFi applications such as Uniswap and Aave. So we come to scalability factor. So Ethereum versus Hedera in scalability. So in Hedera Hashgraph, it is designed to be much more scalable than Ethereum, as it has less concentration on security and more on low latency and high throughput. So it has a theoretical throughput of 10,000 transactions per second, while Ethereum has only 15 to 45 transactions per second because it's more secure and high computation. So Hedera Hashgraph also has much lower latency than Ethereum with average transaction times of less than 5 seconds, whereas Ethereum has 15 seconds. There are a few reasons why Hedera Hashgraph is more scalable than Ethereum. So those are Hedera Hashgraph uses a DAG structure to store the transactions, while Ethereum uses a chain structure. This means that Hedera Hashgraph can process transactions in parallel, while the Ethereum can only process sequentially or linearly. We can see that very well from the structure of how blockchain works and how DAG works. Then Hedera Hashgraph uses a gossip consensus mechanism, which Ethereum currently uses POW, which is a proof of work consensus mechanism. Gossip consensus mechanism is more efficient and scalable. I agree that proof of work is more computationally high and it is, although it's more secure. But still, for scalability and efficiency, gossip consensus is more scalable. Hedera Hashgraph is a permissioned network, while Ethereum is a permissionless network. This means that Hedera Hashgraph has a central authority that oversees the network, while Ethereum does not. So Ethereum provides more decentrality, but Hedera does not. Hedera is limited in that sense. Some specific examples to show how scalability differences are there in Hedera and Ethereum. So micropayments are small payments that are typically made online. Hedera Hashgraph is well suited for micropayments because of its high throughput and low latency. So Hedera Hashgraph is being used by the Hedera Government Council to develop micropayment platforms called Hedera Micropayment Network. Supply chain management is a process of managing the flow of goods and services from raw material to the end customer. Hedera Hashgraph is well suited for this purpose because of its high throughput and low latency. For example, the IBM is developing a supply chain known as the Food Trust. Then decentralized finance, DeFi, is a financial system that is built on blockchain technology. Ethereum is well suited for this decentralized and tamper-proof ledger. So applications like Uniswap and Aave are being made. Non-fungible tokens. NFTs are digital assets that are unique and cannot be replaced. Ethereum is well suited for NFTs because of its decentralized and tamper-proof ledger. For example, Ethereum is being used to develop NFT marketplaces such as OpenSea and Rarible. Overall, Hashgraph or Hedera Hashgraph is more scalable than Ethereum. This makes it suitable for these where we require high throughput and low latency, like micropayments and supply chain management. But Ethereum is more decentralized and tamper-proof blockchain platform. Hence, it is well suited for DeFi and NFTs. So these are some projects that are going on right now in real world in using Hedera Hashgraph. So these are like in the domain of healthcare, privacy tooling, Acer. Then we have ADS Task. This is for advertising. This is for healthcare. This one is Agrio. This is for farmers and financial lenders. Alliance Block. This is for DeFi and to bridge DeFi and TradeFi. So decentralized trading. Then American PowerNet for businesses to buy green power. Then we have Archaea. These are all open source projects in Hedera, which are currently going on. Then this is for infrastructure, API, and platform. Then we have Arcos Energy, which is regulatory complaint Bitcoin mining facilities. Then Avery Denizen, that is connected product cloud by Avery Denizen. So it's based on cloud product and all. Then Attestive, validation of photos and videos and documents. Then AVC Global, intelligent and sustainable supply chain platform. Bank Social, suited for financial services built on Hedera. And finally, Block Science, automated regression marker. We have more projects. Then Ethereum project examples like Uniswap, we have already discussed. It is working on DeFi, decentralized finance. Then we have DAI, which is for smarter currency. Then we have liquidity protocol, Aave, that is. Then we have Curve. Then we have 1-inch network, decentralized protocols, and DeFi. Then we have Decentraland, first ever virtual world owned by its own users, so virtual reality based on blockchain for trade. Then we have Chainlink. Chainlink is very famous nowadays. So it's for by Oracle and decentralized tamper-proof input-output computations, advanced smart contracts by blockchain. And finally, we have the most famous one, Sandbox. So Sandbox is used in metaverse, play and build own games and stuff using blockchain. Thank you. We come to the end of the presentation. So I have covered introduction to both the platforms in detail. I have covered introduction to all their consensus algorithm and scalability factors. I have shown the difference between both of them in respect to with respect to the scalability and consensus algorithm, explaining how both the things work technically, and I have also shown several applications, real world projects and applications that are going on right now using both the platforms.